Okay, so now we're on to the new chapter. So previously we had three chapters regarding light, noise control, and room acoustic, and then heat. So these three topic can be a category by itself. And then after that we have water supply and sanitation and sewage. So these two is quite similar. And then finally we have the storm drainage. So we are now on week 7. I think we just have a nice time period to finish up all our lecture. So in this topic, water supply and distribution, we will have this subtopic. So as usual, we want to know a bit about what it means by water, and then we want to know a bit about hydrological cycle, and then where is our source of water, and how we can treat our water. So this part, water treatment, will be a bit similar to it's quite similar when it comes to sewage treatment. So the method where we treat water for us to use is quite similar to when it comes to us treating sewage. And then after that, you have your external water distribution and reticulation, and then internal. So this is more towards what is the system that we employ for our water supply system, meaning the piping system. And then the sizing of the pipe. So what size is available and why. Then we have our supply plumbing and material and pump principle. So when it goes out to here and here, you'll be more towards not so much. You'll be not so generalized. You'll be more specific. Okay, so as usual, all the material that we have in this lecture slides is from these two book. And then if you want to have additional more information, you can go towards here. So I will always mention that when it comes to learning stuff, a lot of stuff will be available online. But then when it comes to online material, if they are not peer reviewed or they are not from a reputable site, they can be changed at any time. So this sort of information is not really very reliable to put as reference. But nevertheless, they are there so you can you're still in your first year and first semester, so it's always available for you guys to go and refer to. But when it comes to proper research, you want to look towards journal, books such as this, or even peer-reviewed site. Okay, so you learn along the way on how to do it properly. But if you want to take any notes from your lecture slides, so please don't refer to please when you do the referencing, don't refer to lecture slides. Use this or this. So basically, the information for this chapter is all from Macmillan. Okay, so I have a video here. So let's have a look at the video. So this is regarding an introduction of water. Here.
Grammarly does more than catch errors. With Grammarly, you can find really good. No.
Okay, so hopefully you guys get all of that. So if you're interested to have a look at it again, I'll just copy and paste it here. So this one actually is something new that I just added into the slides this semester. So something more interesting as opposed to me talking all the way. So you have some animation behind it. So as mentioned so repeat of what the video said. So basically, our Earth, we actually have a lot of water. So we are actually a water planet. But fun fact where does all this water come from? It actually comes from outer space. So it comes from outer space millions of years ago, drop by drop. And what we have today is a result of that. So not every water is drinkable. Most of the water on Earth if you see it from outer space, it's all on the sea, so it's all salt water. So salt water isn't really very drinkable. So as a video mentioned, because fresh water, the one that we use, is limited, meaning they have to go through a cycle, the hydrological cycle, or we have to get it from the ground. So readily available fresh water is limited lah. That's why we need to have steps taken in order to ensure that we do not run out of all this fresh water. So these are the few steps that we can take to ensure that in the future to come we still have water lah to use. So we can develop water filtration system, meaning we'll have more water. We can filter out more water that we can use. Promote water stewardship, meaning you want to be a champion lah, of reducing the usage of water. It can be through reducing of agricultural water, or usage or less usage of water. So this is what it means lah. You want to reduce the amount of water. And then we want to protect our wetland. So why we want to say wetland is because a wetland is an area where we use it to capture water, such as forests. So imagine if you have a concrete city, that sort of area cannot capture water because it is covered with concrete. So you want to protect a wetland area of rainforest that can absorb the water and replenish the underground water. So this is why we want to protect the wetland. We want to increase irrigation efficiency. So as the video mentioned, agriculture actually use up a lot of water. So in terms of growing crops or feeding up animal, all this takes up a lot of water. So this one we are not able to see it, but in reality, our water consumption basically cause a lot of water wastage from irrigation or agriculture. And then we want to increase our water storage in reservoir so that we will have enough water. Maybe remove salt from the seawater. So if you are very rich, desalinating seawater. And then finally, we still have we can also recycle wastewater. So these are just a few steps lah. There are actually many more steps. Whatever sort of steps that we can take to reduce or ease the world's water needs, this is all acceptable lah. Okay, so talking a bit about the hydrological cycle. So it's a cycle lah in which water change their state from water vapor towards cloud, and then as they drop to become rain, then they will go towards the wetland. So once they go towards the wetland, they drop onto the forest or any ground that is permeable, meaning water can infiltrate into them. Then they will go deep into the ground and replenish the underground water. So this is in the ground, there will be a water table lah, meaning if you dig deep into the ground, let's say maybe 6 meter or more, then you'll reach the water table. So when you reach the water table, it doesn't necessarily mean the water will rush out lah. So it will just means the water is at this level. They will slowly come out and fill up the gap if you dig a hole here. So this is how in ancient time, when a village or when a village have a well, they will put a bucket on top, and then they will dig a well very deep. So because they are using up the water, they will have to dig deeper and deeper, 15 meter or even 30 meter. So why? It's because as the water enter into the well, the water table will actually reduces. It will be something like this. So they will have to go deeper and deeper. So once they use up the surrounding water table, then they'll have to move to another area lah, to dig the well. So slowly by time, if the consumption is very, very high, then this water table will be lowered for the usage here. It will take some time to replenish, so you have to find another new source of water. Okay, so here there's a more detailed explanation of the hydrological cycle. So you have evaporation, condensation. I think you guys learn it lah. So evaporation is just a change in state of liquid water to vapor. So this is how a lot of our liquid is gone. So most of this liquid is from oceans and lakes lah. And then after that, we will have our next process, which is condensation. So this occurs lah when liquid vapor change into liquid. So they form cloud. And then next we have precipitation. Basically, this is rain lah. Can be in the form of water droplet, or it can be even snow. So it can be a solid. And then finally, you have your runoff. So runoff basically just means from rain, they will fall onto the earth, the ground, and then if you say it at the furthest end, so the furthest end will be the rain dropping at the mountain. So from the mountain, there will be the rain will fall on the mountain, and then it will slowly form a river, and where the river will end up is it will be ending up towards the sea as surface water river. Okay, so why is it that the first or the furthest point of contact will be from the mountain? Is because, I mean, if you travel around and you see around, you see that in the scenery, you see that the mountain is so high that the cloud it will actually comes into contact with the cloud. So when that happens, if the cloud cannot travel through the mountain because this is a solid object, so basically if they are dense enough, they will fall on the cloud will precipitate or rain onto this side of the mountain. So in Malaysia, if you look at it geologically, we actually have a mountain across the entire state. So in this left side of our country, we will experience more rainfall. Here will be less because we got quite a long strip of mountains blocking the rain, the cloud. Okay, so this is a hydrological. It's a process in which, if you see here, we have precipitation, and then as we go up, evaporation, we form cloud, and then after that we have precipitation, go down, and then we have some infiltration to replenish the groundwater table, and then all of these they can end up here, or they can be from the runoff, meaning the water didn't seep into the ground. Okay, so when it comes to drawing a water table, it will be something like this lah. So we have a ground, and then we can draw a line below the ground, and then usually we put a symbol like this. So this is to indicate that there's some water presence. So you can put a triangle lah, and then on top of a surface. I draw. Okay, so let's say, for example, this is a surface. So it doesn't matter where the surface is, whether or not it's under the ground or just a cup of water. For example, even if you are to draw a cup of water, the symbol to indicate the presence of water is this. So we draw a triangle, and then if we draw an image of what the triangle will reflect into the water, this is to indicate the presence of water lah. Okay, so mainly we have three sources of fresh water. So we can have groundwater, we can have surface water, or we can have rainwater. So when we talk about groundwater, it's mainly taking up water from the ground. As I mentioned, like the well, we build a well where we dig a hole and we let the water table seep out into this well to fill up the hole. But then there comes a problem lah with this because when it comes to groundwater, if the site or the if beside the site there's some contamination, then it will not be very safe to consume. So where does all this water come from? It comes from the infiltration of water through here. So let's say for example we have some chemical spill or someone is putting some, usually it's chemical lah. So chemical is liquid, so they will slowly infiltrate into the water surrounding here, into the water level, and then it will come out and contaminate the whole well. So it can cause sickness lah. So this is where sickness easily spread. So that's why we have to be very careful lah to protect the water supply, because if we were to get the water from the ground, we will not know where the contamination come from on a area, because the well is getting the water from all the surrounding area. So when it comes to groundwater, you have to be very careful because of a lot of potential health problem. We do not know if anyone can pour something on the ground, then it will infiltrate and go into our water supply. So this is a problem lah when it comes to groundwater. We can access it from everywhere, but then if there's some contamination, then it will not be very fit lah for human usage. So next we'll have surface water. So surface water is river water. So because Malaysia, we are a tropical country, so we actually have a lot of catchment area, and then all this catchment area will in turns into river and stream. So when it comes to usage of or using or collecting the water, we want to ensure it that it comes from as high as possible lah. Meaning we want to collect it at upland. So if we are collecting at the middle of the river, we actually do not know what's going on lah in between the middle to the starting point. So we want to collect water from as near the starting point as possible. So at the start of the river lah. So when you say at the start of the river, mainly is near the mountain. And then water collected near the start of the river tends to be soft and good quality because there's not much contamination. So a river goes for travels for a very long duration to end up at the sea. So during this time, from the beginning to the end, the journey of the water in the river, there will be a lot of animal using up the river. So in case of water animal like crocodile in the river, and then even animal drinking, and then when they drink, they have their business on the river also. So it can cause contamination. Okay, so to ensure the water is of good quality, you want to ensure that this is colorless, free from small particle or matter, and then free from harmful bacteria. Okay, so here it mentions soft and of good quality. So this one comes in regards to the properties of water. So this one will be discussed in a bit more detail later on. Okay, so then finally we have your rainwater. So rainwater is a original source of water used for drinking. So then there's a problem with rainwater lah, because only when it rains we collect it. So it's not a very reliable source of water, and then there's also a missing in presence of mineral lah, because rainwater is not does not contain any mineral that our body requires. So it's not so preferred lah. But when it comes to collecting and using rainwater, they are quite clean. Okay, so when it comes to quality of water, water is actually a universal solvent. So yeah, universal solvent, meaning a lot of substance can dissolve into water. So in many cases, naturally found water, they are not chemically pure, meaning there's a lot of matters in the water. So by right, if the water is pure, they will not have any color. They will not be brown or even green. So they don't have any taste or smell, and they are pH neutral. So they are not acidic or alkaline. But then when it comes, because water is a universal solvent, so a lot of substance or material get dissolved into water. So this can affect them in terms of color, taste, and then they can even smell, and then it will also affect the alkaline or the acidity of the water lah. Okay, so they can be contaminated with inorganic matter or organic matter. So it can be minerals. When it comes to organic matter, then organic matter, it will be fecal matter or even animal lah, or microscopic organism, bacteria, and then any pollutant. So this one will be chemical, and acidity. So regarding this is regarding the pH value, and then hardness. So a water can be either soft or hard. It depends on the mineral inside the water. Okay, so for here, by right, water, pure water is chemically pure, which means 7. But because natural water can dissolve a lot of material inside it, so any naturally sourced water, they are in between of 5.5 to 8.5 value. So they can be either acidic or alkaline. That's for natural water. So acidity, if they are if they are high in acidity, this is usually caused by dissolved carbon dioxide and dissolved organic substance such as PET. So acidic water can also be from lead, from tank or pipes where we use to transport our water. So this pH value, is just a measure of acidity and alkalinity of a solution. Basically, it means if you are more than 7, less than 7, then they are either acid or alkaline. So we do not want them to have a too high or too low of a value lah. Meaning if there's too much, if they are too high in acidity or too high in alkaline, it's actually dangerous for us to drink. But usually in a range of this, it will be alright lah for our body. But if it goes beyond that, then it will be dangerous for our health. So this is the idea lah in determining why we want to measure either it's a acid or alkaline. Okay, so next we have your hardness. So only two info lah will be discussed in your slides. So when it comes to regarding other matter like organic, inorganic, or organic, so we won't go much in that. Even microscopic organism, bacteria, we also won't go much in that. So we just go very briefly on the pH, on what's the idea behind acid and alkaline, and then also a bit on the hardness of water. So water can either be hard or soft. So when it comes to hard water, it will be a water which is difficult to obtain a lather, meaning you will be hard to get the soapy texture with the soap. So generally, surface water are soft, ground water are hard. So what determines a water is either soft or hard is by the amount of calcium and magnesium. So generally in Malaysia, because we are using, we have a lot of river water, so we are more towards soft water supply. So it doesn't necessarily mean the whole Malaysia is all soft water lah. So when it comes to what makes water soft, is all based on this calcium and magnesium. Sometimes the supply, the water supply that we get in Malaysia might be from underground, so it will be hard water. So but generally, the water supply in Malaysia is more towards soft water supply. This is because we get most of our water from the river or from the dam So there's dam at different state. Not every state will have a dam, but usually if you were to get our water supply from a dam, then the water that's being supplied to us is a soft water. Okay, what it means by soft water is that when the level of calcium and magnesium is lower than the sodium or salt, so this one is the same thing then it's considered soft water. But if this calcium and magnesium is high, then they will be considered as a hard water So we actually have a measurement of scale. If you go towards the Shaba's website, there's actually a value in which the calcium and magnesium needs to reach in order to be considered as a hard water. If I'm not mistaken, it's something like 60 milligram per liter. So this one, you have to. It's not important but this is not important. But generally, this is the principle that you guys need to know. So when it comes to that sort of guideline, as I mentioned, online there will be some guideline, but for your course, it will not be required So maybe I can do a quick search. So it's somewhere. So let's refer to here lah. So this is actually from Wikipedia. So by right we should have some other by right. If you look towards the document, then there should be a guideline lah from Shabas. So different state they will have their own government body. So in Selangor we call it Shabas. In other country, in other state, then there will be other name lah. So there will be different classification. This one is not important lah. Just to show you how we can classify whether or not a water is soft or hard. So it can be in terms of how many value, how much the material is there, is present. So just a showcase if the material in terms is above that value, then you consider it as either a moderately hard, a hard or very hard water. So there's a difference in between a soft water and a hard water. So here, we will discuss a bit on the advantages and disadvantages. So we can waste fuel because there will be scale in boilers and pipe. So because the water is hard, they contain a lot of mineral. So as they travel in through the pipes and boilers, they will leave these minerals behind. So once they build up, we call it as a scale. So this scale will actually reduce the pipe size diameter, meaning they will slowly build up and they will cover up the pipe. So we do not want that because hard water contains a lot of mineral. As they travel, their material will settle and then they will start building up and start to block the flow of the pipe. So we waste fuels if you want to replace it, or we are wasting energy because this pipe is not doing the maximum transfer. So you can also have deterioration and damage due to the scale. We waste soap and energy to form a letter. Okay, so then next we have increase in wear in our texture because we need to wash it longer due to the hard water having a harder time to form a letter. And then you have your industrial process affected by the chemical in the hard water. And food and drinks is also affected by hard water. So in different part of the world, depending on where we get our source of water, it can be either hard water or soft water. There will be different mineral content inside the water. So all these different content will actually have a effect on our food and drinks. Okay, and then but there's some advantages to hard water. So it's less toxic. Lead is dissolved from pipes by hard water because it's already full of mineral. And then you have better taste because it contains the required mineral. And then this is some health related advantages. So mention again on the difference of where the soft water and hard water can be obtained is from rainwater or distilled. So the level of mineral is low. And then you have hard water is usually from underground. So if you notice here, there is no, although there's no mention of advantages and disadvantage of soft water. So as of now, this is what you have. So the difference between soft and hard is that soft water contains higher level of salt. So maybe in the future I will add in then it will be included in your syllabus. Okay, so let's have a quick